Alrighty, why don't we go ahead and get started? So this is the Prometheus maintainer track. I'm going to be talking about, you can't hear me? Do I need to talk a little bit closer? Okay. Wow. Okay. All right. This is the Prometheus maintainer track, and I'm David Ashpole. I work for Google. I wear a lot of hats. So as you may notice, I have one of the OpenTelemetry maintainer shirts on, but I'm also a Prometheus team member, which is why I'm here giving this talk today. Unfortunately, my co-presenter, who actually did most of the work for these slides, was not able to make it because he's in Europe. So you guys get to listen to me for half an hour today instead. All right, if you've been to a Prometheus talk before, you may recognize this. Has anyone heard of Prometheus before? Show of hands. All right, keep them up if you've used Prometheus before. Keep them up if you use Prometheus in production. And last and not least, raise your hand if you know what the plural of Prometheus is. It's Prometheis. Listen to the talk. It's really funny, actually. All right. For those in the audience who haven't heard of Prometheus before, Prometheus was originally developed by SoundCloud and inspired by actually Borgmon from Google. And it's a monitoring and alerting system. And it was the second project to join the CNCF after Kubernetes. Roughly speaking, Prometheus is broken down into an ecosystem of exporters. So your custom application may have a Prometheus exporter endpoint on it, but there are also common ones like node exporter or cube state metrics that expose metrics in Prometheus format. Then there's the Prometheus server, which is in charge of discovering the endpoints that need to be scraped, doing the actual scraping of that metric data, storing it in a time series database, and making it available for querying and alerting using PromQL, which is Prometheus's query language. Alerting is very important so that you know if your production is on fire or not. So Prometheus is depended on all around the world for making sure that production systems everywhere are available. Prometheus was originally started work on in 2012 and has gone through a lot of iterations since then. One of the biggest milestones was the project's graduation, which means that the CNCF deems it to have reached a high level of maturity, have strong governance, a large contributor base, and lots of people using it in production. But we've been busy, and if you've been paying attention for the last year or so, Prometheus 3.0 was a big deal, came with a lot of new features. And today, in November of 2025, we've most recently released the 3.7 release. So that's where we are today. So what am I going to cover today? We've done a lot of work on OpenTelemetry compatibility. So that includes deltas, oh my goodness. It includes keeping the original OpenTelemetry names with dots, even improvements to resource handling and scope handling. I have a couple updates on native histograms. They're finally stable, hooray. And there's a new cool thing around called native histograms custom buckets. What are those? And finally, there's been some improvements to PromQL. So without further ado, let's talk about OpenTelemetry. The Prometheus server supports OTLP at the standard OTLP path. And so actually since 3.0, Prometheus has supported pushing metrics to it, which is, for me, kind of crazy. And you can do that in OTLP format. But we've gotten a lot of feedback, we've done some surveys, and there's a lot of improvements that we've been trying to make to the OpenTelemetry experience of using Prometheus. So first, you may think that Prometheus and OpenTelemetry were enemies, were competitors, but that's not actually the case. Prometheus, a while ago, actually published a big blog post committing to supporting OpenTelemetry. You know, it has made many different design decisions, I'll say, and you know, there's definitely been friction between the communities, but we in the CNCF are working hard to make sure that the projects work well together and can be used, you know, in a variety of mixed ways. But it's still a work in progress, and sometimes you need to turn on experimental features to have it work as intended right now. So this is still not quite there, but we've been making a lot of improvements. And there's a nice guide on the Prometheus website telling you exactly all the details of what to turn on, what not, and what some of the trade-offs are that you have to make there. Okay, one of the most requested features since 3.0 is to be able to keep your original OpenTelemetry metric names. OpenTelemetry is built around the idea of semantic conventions that, a metric should have one name and one name only and should have exactly these set of labels, like stuff like that. And so a lot of people had asked to be able to keep that original structure, even when sending it to something like Prometheus, which most people expect to have underscores sprinkled everywhere and unit suffixes and that sort of thing. So we've introduced a new translation strategy option, and one of the options that we've added recently is the no translation option. There's some gotchas, though, which I'll get into. So some of the changes are changing like dots to underscores that happened before this, and also adding suffixes. So let's talk about type and unit. So Prometheus has always recommended strongly that you should include a type hint in your metric name, like underscore total, and that you should include the unit in your metric name as well. So Prometheus names are typically named something like HTTP request duration seconds, total, I guess, if it was a counter. But OpenTelemetry doesn't do that, right? OpenTelemetry is http.request.duration, and if you're looking at this in a YAML file, good luck. Hopefully you can remember what unit it was. So to partially address that, one feature that we've worked on is called the type and unit labels feature, and we do recommend turning this on if you're ingesting OpenTelemetry metrics via the OTLP endpoint. What this does is it adds type and unit as labels on the metric, so that if you do end up, say, ingesting one metric that's in seconds and a different one in milliseconds, you can actually disambiguate them later at query time. And the hope is also that this will be used to provide richer user interface experiences as well by making type and unit more readily available. But we're still looking for feedback, so if you love it or hate it, make your voice known. OpenTelemetry is working on Delta support. It is in the super duper duper early stages. So when we ingest Delta counters, mark them as unknown because Prometheus, they're obviously not the same as traditional Prometheus cumulative counters. But this is going to be an area that I think improves slowly over time. Things like adding start time stamp support, and there's obviously going to be a lot of work on the storage and query layer required for this as well. But the very beginnings of this has already sort of started. And if you want to play around with it, I would say it's in a state where if you do happen to have Delta metrics, they are usable in some cases, but do have some pretty severe limitations. Another massive area of feedback has been dealing with OpenTelemetry resource. So OpenTelemetry sticks a ton of metadata about where a process is running in resource attributes, and not just like 1 or 2 resource attributes, but like 20 or 50 sometimes. So dealing with these in Prometheus and in the data model can be a little bit tricky. If you promote them all, well, one, you've added tons and tons of labels to all of your metrics. It clutters up your UI, and that's not really a great solution. But if you've been following the mapping up until this point, you can also take them and just stick them in a different metric called target info and make everyone write a nice long join query. So that also has some problems. And instead of picking one of the 2 approaches, we've actually kind of been trying to make both approaches a little bit better supported. So first, if you want to take the approach of promoting resource attributes into your Prometheus labels, we've added better support for that. So now we have an allow list and a deny list, essentially. So if you want to add in certain resource attributes whenever they're present, you can use promote resource attributes. And then if you want to add in all resource attributes except for those problematic ones over there, you can do that with promote all of them and then ignore resource attributes. And then there's separately one special for the service resource attributes called keep identifying resource attributes. And you can, learn more on the website there. There's actually some pretty good best practices there. So if you're looking for the copy, paste, and forget version of this, it's probably right there. Second, we do put all the resource attributes in a metric called target info, but we've gotten a lot of complaints over the past year or two that this is basically unusable for most people. You can see the query you have to write here is quite long compared to just the thing that you were trying to do, which is get your HTTP server duration over the last 2 minutes, right? So that's a pain in the butt. In order to try and make that experience a little bit better, make the queries more readable, and a little bit more ergonomic, we've introduced the info function. So the idea here is that we want to add some, we want to just make joining with an info metric across Prometheus generally a simpler concept. And so you can see it actually does simplify it quite a bit, and it's maybe a little bit easier to tell what's going on, which is that we're trying to add the Kubernetes cluster name to the metric that we're querying there. And that has to be enabled with a feature flag for experimental PromQL functions. And I think finally, we've added a little bit better support for OpenTelemetry scope. So if you've ever been debugging a metric and you're like, who the heck defined this? That's what OpenTelemetry scope is meant to answer. So it tells you usually the package name where the metric is defined and also includes the version. So it can be helpful to catch regressions if a metric broke, or if you're seeing, as was the case before, one metric in seconds and another in milliseconds, you can kind of figure out who the culprit was, who defined their metric not using base units. Those are opt-in still. So there's a promote scope metadata option there that you can turn on to get those as labels. All right, let's talk about native histograms. Native histograms are an awesome new feature that comes with Prometheus 3.0. For more details on exactly how they work and why they're awesome, some of the previous talks are probably going to be better than this. But I'm going to focus today on something called native histograms with custom buckets, which when I first heard it sounded kind of bizarre. Like, isn't the whole point of native histograms that they have exponential buckets? All right, so we'll start with an overview of the classic Prometheus histogram today. This example has 6 individual samples, right? There's 4 of them that have the bucket suffix with the LE label, right? Meaning less than or equal. And each series has the count of observations that were less than the threshold, right? Most people are pretty familiar with this. There's also a sum and a count series. On the other hand, native histograms, even though they're full of information, right? They're very dense, oftentimes could have like 100 buckets. They're only stored as a single data point. They're stored as a single complex sample. And it turns out that, especially in the TSDB and the query layer, that is actually really, really efficient. So the logical next step is for someone to say, hey, why don't we just store all the histograms as a complex sample type, right? So it turns out, why not take our regular histograms and turn them into this complex type and store them that way and query them that way so that we get all these efficiency gains. And so that's what was implemented, and that's called native histogram with custom buckets. There's mostly one catch to this, which is that if you're familiar with native histograms, they're not individual series anymore, so you can't query for them like that. There's no series in a native histogram that has the underscore bucket suffix, for example. Instead, you have to access fields in that complex histogram type by using functions on it. So I might use the histogram count function to get the count of a native histogram. So when you migrate, or if and when you migrate to native histograms with custom buckets from classic histograms, you'll need to change your queries as well to actually query using these new native histogram functions. The folks that worked on this I think, thought through a lot of different migration cases, and they have a couple different config options that you can use to either write just the classic ones, both, or just the new native histogram custom bucket versions. So definitely something worth trying out. And yeah, there's some real benefits to using this. All right. For a fun, let's look at a bunch of the features all in one view. Here we have a metric that is using UTF-8 support, so it's got some dots in it, right? It's a native histogram, so as you can see, it is this a native histogram? I think it's a native histogram. And it's also queried on the new Prometheus 3.0 user interface. So this is actually showing off a bunch of the cool new features all in one view. And adjusted via the OTLP endpoint. And finally, let's talk about some of the changes to PromQL. These are all new feature additions, so it's a great time to offer feedback on them or play around with them, find and report bugs, things like that. So first, this apparently has been open a while, but is finally getting looked at, which is now you can finally use plus or minus in durations. So I can do 9 minutes and 2 seconds by writing 9 minutes plus 2 seconds instead of having to write 542 seconds. It doesn't yet apply to the @ offset, but hopefully that'll come in the future. Next, it turns out it's quite expensive to query for timestamps of metrics, and Prometheus doesn't have a general way to say, I'd like to query for a bunch of timestamps and do math on them. There's a timestamp function, but that has a lot of performance issues from what I've read here. Instead of trying to work towards a generic solution, for now, they've tried to address the most common use cases of querying for timestamps with these new functions that they've added. So timestamp of min or max or last over time. And so if you have encountered this, there are now fixes, but if your use case isn't met, it's probably also a good idea to raise your voice too. All right, finally, I think this is actually really cool. So there's now support for a little bit more control over how extrapolation works in PromQL. So there's 2 new keywords that are supported. One is anchored, and the other is smoothed. So if you look at how currently PromQL deals with missing data, so on the left, man, I'm bad at left and right. On the left, you can see what Prometheus does today if there's missing data. It'll show you the 2 pieces that it knows about. And for example, if you measure the increase, it'll show you the portions it knows about, which adds up to about 6 in this case. If you use the smoothed keyword, I think it's called a keyword. If you use the smooth keyword, Prometheus does a lot more interpolation. It ignores, for example, staleness markers and just linearly interpolates between points that it knows. So if you've ever looked at a Prometheus dashboard that has some intermittent data or data missing, you'll just see a scatter plot, and it's not very useful. This is potentially more useful in situations like that because the UI will then, or the query engine will then draw smooth lines between all your points and make it a little bit more usable. It's maybe harder to see that data is missing, but it's closer to probably what the original data was supposed to be. There's a big catch with this, though, which is that it requires a data point before the query window and requires a data point after the query window to look correct. This is mostly really important if you're talking about recording rules or alerts, because let's say you had a constant line going across, it doesn't have a point in the future if you're querying all the way up to now, and so you'll see it drop off. That's the case in some other monitoring products as well. But if you're doing an alert and you're looking at the data that's dropped off because it doesn't have data in the future yet, you might get the wrong alert value. So there's good documentation on exactly how to handle that if you still want to use the smoothed rule, but just be careful using this. It's great for dashboards and probably is something you'll want to play around with, but you just have to be careful with looking at time that's really close to the current time where you might not have the most recent data yet. Now let's talk about anchored. Show of hands again. Who has ever queried for an error metric only to be confused as to how you got 3.75 errors in an interval, right? That's a pretty common piece of confusion. How the heck can you query over a bunch of integers and get a float, right? So that's where the new anchored keyword comes in. So it doesn't do any fancy extrapolation. It doesn't do any interpolation. It just gives you exactly what the change was between the values that are in the time series database. So if the last value was, what is it here? If the last value is 4 or 3, and then the next value is 9, it's not going to try and draw lines all the way between them. This is, let's see. This avoids over-interpolation. So it's generally, it's making fewer assumptions, and it can be quite useful for like business metrics use cases where you don't really want it to be an overestimate or to be guessing as to what comes next, right? And if you're querying with an increase on integer data, you will only get integers back. So in many ways, that can make dashboards on things like errors much, much easier to actually understand. All right. There's also been some recent changes in governance. So we did a big batch of new team members, and that was a good process, and I think well-deserved for them. So here are the people that were added recently. And as you can see, there's actually quite a good mix of companies represented here, which is very exciting for the project. We're working on a new 2.0 of the governance structure and are trying to mimic more the other CNCF projects in terms of project structure. So right now, Prometheus has just a group of team members, myself included, but we're moving to a model that's more similar to other projects where there'll be contributors, members, maintainers, and then a smaller steering committee that makes the hard decisions. All right, there's a ton of stuff that's happening that's going to be part of the next KubeCon talk in EU or North America next year that you can be a part of. So, and yeah, I'm excited about a lot of, like, there's much to do with Delta support. There's open metrics, which is, we're working on a 2.0, and that's extremely exciting. And there's a bunch of other really useful features that we need feedback on, but also appreciate contributor help with. So if anything excites you, get involved, talk to me afterwards, and I'll try and connect you with the right people. Slack is also a great place to leave feedback. If you see anything today that you love or that you hate, like, let us know. There's a variety of channels here for different topics. All right, I'm happy to take questions now. I think we've got 5 minutes.
This turned on. Wait. It's on. Okay.
on?
Yeah. Do you plan to do anything about the initial zero problem?
Say that one more time.
Initial zero problem, where, you know, when the metrics comes in, it's not set to 0, and then something, you know, get reported, but when you're running rate function or increase function, it doesn't return anything because there was no 0. So
I'm not familiar with this specific problem. I do know that a lot of the weirdness around querying when a metric initially started is in some respects addressed by adding created or start timestamps, because then we actually have a point at a timestamp with a 0 value. But again, I'm not super familiar with that exactly, so I'm not sure if that'll fix it or not.
okay.
Hi. I have a question not related to the topics in the talk, but mainly regarding the wall corruption in Prometheus. I know a lot of these wall corruption issues have been fixed over various versions, but we still keep hitting them occasionally. And the only way to fix them is to, go in and just rm minus rf the wall directory. So is there a plan to add it in prompt tool where Prometheus can automatically handle this or provide some tooling around this?
I'm unfortunately not like an expert in the TSDB. I encourage you to open an issue or look for existing ones. If it sounds like a useful feature. Prometheus sometimes will solve problems like that itself, and sometimes it expects like an operator or some wrapper, like something managing it to solve it. So I'm not sure. Maybe I don't know if you know, but
okay, thank you.
Yeah, you're welcome. All right. Thank you, everyone, for coming. Thank you for coming all this way out to C11, 111.